All right, let's get into it. Have you ever been on a plane, maybe looking out the window, and just had that thought, how on earth is this thing staying up here? Today, we're going to crack the code and dive into the incredible physics that lets these massive machines just soar through the sky. I mean, seriously, think about it for a second. We're talking about a 500-ton metal tube packed with people and luggage just hanging out in the air. It feels like it should be impossible, right? But the answer, well, it's just a beautiful piece of science. So to solve this mystery, we have to start with a fundamental rule of physics. It's kind of the secret ingredient to the whole recipe of flight, and it's called Bernoulli's Principle. Okay, Bernoulli's Principle. I know, it sounds a little intimidating, but don't worry. The idea itself is actually super simple. All it says is that when a fluid, and yeah, the air all around us totally counts as a fluid, starts moving faster, its pressure goes down. That's it. That's the golden rule you need to remember. So you can basically think of it like this. Fast air means low pressure. Slow air means high pressure. It's like a seesaw, you know? When one side goes up, the other has to come down. This simple little trade-off, that is the engine that's going to get our plane off the ground. Okay, so we know we need fast air and slow air. But where does a plane make that happen? Well, it all comes down to the most important part of the plane for our story today, that brilliantly designed wing. And here's the clever part. See, a wing isn't just some flat board sticking out the side. This special shape, it's called an airfoil, is sculpted for a very specific reason. Look at that curve on top and see how it's way flatter on the bottom? That shape right there is the key to everything. So how does this magic shape actually work? Well, as the plane rockets forward, the wing just splits the air in two. The air that goes over that curved top has a longer way to go, so it has to speed up. The air that goes underneath gets the easy, shorter, flatter path, so it moves a lot slower. Now, if we remember our buddy Bernoulli, and this is where it all comes together. That super fast air on top creates a pocket of low pressure. Meanwhile, the slower air underneath has higher pressure. And nature, well, it hates an imbalance. So that high-pressure air from below gives the wing a massive push upwards. And that amazing upward push, we call that lift. But lift is only one part of the story, right? To really get how controlled flight works, you gotta see it as this constant four-way battle that's happening every single second the plane is in the air. Yeah, it's basically a big tug-of-war in the sky. You've got lift pulling the plane up, while its weight, gravity, is trying to drag it straight down. At the same time, the engines are creating thrust, pushing it forward, while the air itself creates drag, trying to hold it back. For the plane to climb, lift has to be stronger than weight, and to just cruise along, thrust and drag need to be perfectly balanced. It's a constant dance. And this is where the pilots come in. They can actually tilt the nose of the plane up, which changes the wing's angle of attack. By doing that, they force even more air downwards, and you know what Newton said, for every action there's an equal and opposite reaction. That reaction gives them an extra boost of lift, super important for things like takeoff. But you gotta be careful. There's a limit. If a pilot pushes that angle too high, the air can't stick to the top of the wing anymore. It just breaks away into messy, turbulent chaos. When that happens, poof, the lift disappears. That's what a stall is. It's this incredibly delicate balancing act. Okay, I know all this talk about pressure and angles can feel a little theoretical. But what if I told you there's a super simple way you can actually feel the force of lift for yourself? Next time you're in a car, and be safe about this obviously, try sticking your hand out the window. Your hand becomes a little mini wing. Now, tilt it up just a little bit against the wind. You'll feel it, right? That upward push on your hand. That is exactly the same force. That's lift. All right, so let's put it all together one last time. It all starts with the wing's special shape. That shape makes the air on top move faster. Faster air means lower pressure. Slower air underneath means higher pressure. That pressure difference creates the upward force we call lift. And if you have enough lift, you can beat gravity and send a 500-ton machine soaring through the sky. Pretty cool, huh? It really is an incredible dance between physics and engineering, isn't it? So the next time you're on a flight, buckled in your seat, and you feel that amazing rumble of takeoff, take a look out the window and just think about that invisible river of air working its magic, holding you thousands of feet up in the sky.